Hello friends, welcome to Crack Gate CSE, and in this series of algorithm today we'll be understanding that how you can find out or how you can create a binary tree using the pre-order or in order and if the post order and in order is given. So there is a very simple set of rules using which you can find out the binary tree, right? So this question is very important. So please watch each and every minute of this video because these kind of questions can come in your exam and these simple questions can make a huge difference, right? So first of all, what we will be understanding in this question, right? So here you can see that I'm having an example in which this particular binary tree data is given. So here you can see that the pre-order and in order is given and they are asking about the post order. They are asking about the third order which is not available. And in the second question you can see that post order and in order is given and they are asking that how you can find out the pre-order. So for that what we'll be doing is using these two orders. First of all we will be creating a binary tree. Then using that particular binary tree we will be traversing and finding out the post order, right? Same we are doing with this question. We will be creating a first binary tree using the post order and in order sequence that we have, and later on we will be traversing that particular tree which we will be finding out using these two sequences to find out the pre-order. So here we have to find out the post order and here we have to find out the pre-order, right? And later on we will be understanding that why this in order sequence is required to find out the binary tree data. Because if we are not having this in order, let's say that there is some example in which we are having pre-order and post order only. So whether it is possible to find out the binary tree using the pre-order and post order? If yes, then what is the procedure, and if no, then what is the limitation? So we'll be understanding that thing as well in this particular video. So be with me in this particular video, and in case if you have not checked my previous videos, please check those previous videos because those videos are very helpful for your competitive exam and for your semester exams as well. Now let's start with this first question. So in this first question you can see that here I am having pre-order and in order. So in pre-order, what is the sequence? We know that root will be at the starting, then there will be left, and then there will be right. So in pre-order we have root, left, right, and in order we are having left, root, right. Now how you can do that? See, in from pre-order you will be getting the root, then you will be finding out that particular root element in the in order. And once you find out the root, then you will get an idea that how many elements are on the left of that root and how many elements are on the right of that root. So using these two simple rules, we will be creating a binary tree first, right? So let's start. First you can see that here I am having D. So in pre we are having root first, so we are having D. So I am creating a node with element D. Now find out that D in this in order. So here you can see that here I am having this D. So all the elements which are on the left hand side, this one, are on the left of this D. Similarly, you can see that here I am having root now. So because of this root, whatever the element we are having on the left hand side will be on the left subtree, and whatever the element I am having on the right hand side will be on the right subtree, right? Now again go to the pre-order, right? In pre-order you can see that next we are having C. So now traverse this C in order. So here you can see that here I am getting this C. Now this C is in the left of D. That means this C node will be here on left of D. Now using this C we can find out that A and B will be on the left of C because root, left, right. So this AB will be on the left of C and this F, G, E will be on the right of this C, right? Next traverse the next element in the pre-order. So we will be checking one element in this, then we will be finding out the position of that element in the in order and create a node. Again go back to the pre-order, find out the next node which is C, then come back to the in order and find out the position of C and create a node. So this would be the procedure to complete this binary tree. Next you can see here I am having B, and here in order we are having B at the left of C. That means B will be somewhere here, right? And in the left of B will be having A. So again move on to the pre-order. We came to A, and this A is on the left of B. So this much part is done. Now move on to this E. This E is on the right of C, because you can see here the E is. So this E is on the right of C. So right of C is this, that means E will be here. Again move on to F. So this F is on the left of E. Left of E, that means F will be here. Next move on to G. Now you can see that this G is on the right of this F. We have done this F. So on the right of this F we are having this G. So this G will be here. So same you have to traverse these pre-order and in order so that you can find out the complete tree. Try to do it by your own, otherwise I am doing it for you, right? So this G is done. So this is how it is going, then F and this G. Now move on to this I. Now you can see this I is here. So this HML will be on the left of I, and this JK will be on the right of I. So I am creating a tree, a node I which is on the right of D. So I will be here. Traversing next element which is H, and this H is in the left of I. So this H is here, and this ML will be on the right of H. So H is where? On the left of I. So H will be here. Next traverse L. So this L is present here. That means on the right of H we will be having L. So what is the right? This is the right of H. Here we are having L. And this M will be at the left of L. Next is M, and this M is at the left of L. Now move on to this J. So this M is done. Now move on to this J. This J is in the right of I. That means here. And next is K. So this K is on the right of J. So here. So you can see that how simple it is to find out the binary tree. So we got to know that we are having this kind of binary tree structure using this two order which is given. One is pre-order, another one is in order. Now what we have to do is we have to find out the post order using this tree. So just traverse this tree and find out the post order. I already explained you some questions of this kind in the previous video. So if you haven't checked these videos, please check those out, because those videos will be very helpful. So now we have to find out the post order. And in post order, you know that first we'll be having left, then we'll be having right, and later on we'll be having root. So start from the root node and go to the extreme left. So what is the extreme left? Left is C. Then again, first of all move on to D. Then you have to find out left of D, C. Again you have to find out left of C. Again you have to find out left of B. You came here. Again you have to find out left of A. So there is no left of A. Now you have to find out the right of A. So there is no right of A. So you can finally print the root. So here you will be having A. Then traverse back. So for B, left is done, but there is no right. So then print the root. So B will be printed. Now you move on to C. Backtrack to C. So this left part is done. Now you have to move on to this right. So you came here on this E position. On E also you have to check left, right, root. So on the left of E we are having F. You came back here, and from this F you will check left first, but there is no left. So leave it. But then you have to move on to the right. So here we are having this G. At G also you have to check left, right, root. So there is no left, there is no right. So print G. Backtrack to F. Left and right is done. So print F. Backtrack to E. here. So left is done, no right, print E, right? So in the same manner you can print. So I'm just writing down the complete sequence because I already explained you that how you can do it in the previous videos. So please refer the previous videos, it will save your time as well as my time. So in case if you are not getting any idea, just follow this left right route starting from this D, and you can easily find out that this will be the post order, right? Let's move on to the example number 2. Here we are having the post order and in order, and we have to find out the pre-order. So what we have to do, we have to use this post order and in order sequence and try to create a tree using these two sequence. And after creating the tree, just like we did over here, we'll be traversing it to find out the pre-order. So how we can do, let's see. Start with the post. So before starting with the post, let me tell you that in the post order we are having left right root. That means root will be at the last, that means at the rightmost place. So we'll be starting our scanning from here because root is available at the end. So start. So first K will be root because K is available in the end. Then find out this K in this in order. So you can see that here I am having this K. That means all the elements which are on the right hand side of the K will be on the right of this node, and whatever the element which are on the left of this K will be on the left hand side. Now come to J. We are scanning from right to left. Here we were scanning from left to right, but if post order is given, you have to scan from right to left because root is available at the rightmost position, right? So this is the general idea that how you can proceed. Just find out, just scan the question and find out whether pre-order is post order is given. In pre-order, root is at the starting, and in the post order, root is at the end. Now you came back to J. Scan this J. J is in the right of K, so J is here. Again come to B and scan this B. So this B is available here. That means all the elements which are on the left of B will be on the left subtree, and whatever the element we are having on the right, so these are the remaining elements, these will be on the right subtree for B. So B is on the left, so I am creating a node B on the left of K. Move on to the next A. So again scan A. A is on the right of B, so A will be here. So these 5 elements will be on the left of A, and these I will be on the right of A. Come to I. This I is on the right of A, so I will be here. Come to D. So this D is on the left of A, so D is here. So this D is done. So E will be on the left and FGH will be on the right. So come to G now. This G is on the right of D. So this G will be here. This G will be here. Next move on to this H. This H is on the right of G. So H will be here. Next F. This F is at the left of G. So F is here. Now come to this E. This E is on the left of D. So E will be here. Now this C is on the left of B. So C will be here. So this is how you can find out the tree. Now you have to find out the pre-order. And in pre-order, you know that first there will be root, then there will be left, and then there will be right. So go to the root first, K, and print it. Now move to the left. So you moved on to the left, which is B. Again start root left right, so print this B. Again move to the left, C, and print this C. Now this left is done for B. Go to the right, that means A. Print root. A is printed. Move left, print root. D is printed. Move left, print root. A is printed. Now this left is done, you have to move right. Move on to the right. So move right, print root. Again move left, print root. Then move right, print root. Backtrack. So this is done. So left of A is done. Now move on to the right. So this I is done. Now backtrack. So this part is done. J is left. So this is J. So this will be sequence K, B, C, A, D, E, G, F, H, I, J. So this is how you can find out the pre-order and post-order if any other two sequences is given. Now we'll understand that what is the time complexity to find out the binary tree on such orders using these scenarios. So if pre-order or post-order is given along with the in order, it will take order of n square in the worst case. Let's see how. So time complexity will be order of n square in the worst case. How? Let's see. So here what we was doing is we are scanning one element, and after scanning this one element, we are searching for that element in this in order. That means for this k value we are scanning this n values. After we found out, we are moving on to the next element. Again we are finding out this j, and again we are scanning for this next. So what we are doing over here is we are checking one value in the post order and we are finding that value in this in order. So if we are having n values here, that means we have to scan each one value out of these n times. Here we are also having n, that means n into n will be n square. So the worst case time complexity is order of n square. Now we'll be finding out that what you should do if pre and post order is given. So here we have understood that how you can find out the tree and the post order pre-order if pre or in is given and post or in is given. But what if pre-order and post order is given? Then what are the possibilities? What you can exactly do? So now we'll be understanding that. In this example, you can see that here I'm having pre-order and post order. So pre-order is A, B, C, and this post order is C, B, A. So using this particular example, we'll be understanding that whether it is possible to create a binary tree using pre-order and post-order. If yes, then how we can do it. If no, then what is the limitation. So first of all, let me make it very clear that using this pre-order and post-order, you can create a binary tree, but that need not to be unique, because see, we are having ABC, and in pre-order we know that first will be root, then we are having left, then we are having right. So if using this sequence you try to create a binary tree, so A will be the root, so A will be the root, right? Then after root we know that there is a left, so this B will be on the left. Then there is the right, that means this C will be on the right of the root. So one is this possibility, right? But if you try to create using this particular post order, and in post order we know that this root will be on the rightmost place, so this A will be root, right? And the one which is here will be on the right, so B will be on the right, and the one which is on the leftmost place will be on the left, that means C will be on the left. So here only you can see that this pre-order is giving you the different tree and this post-order is giving you the different tree. Apart from this, you can see that what are the different possibilities that you can have a binary tree using these three. So I'm just giving you some examples. So one possibility is A, B, C. Another possibility is you can have a tree like A, B and C on the right. Similarly A, B on the right and C on the left of B, and this A, B on the right of A and this C on the right of B. So here you can see that these are the two possibilities. So this has been created using the pre-sequence and this has been created using the post sequence. Now if you try to find out the pre-order of any those, that will be equal to ABC, and if you find out the post order of any those, that will be equal to CBE. Try to check it by your own and just let me know if you are not getting the same thing. So you can see that here we are having 6 different trees available in front of you, but these 6 different trees are having same pre-order and same post order, right? Not 6, these 5 are having same post order and these 5 are having same pre-order. So here you can see that a wide variety of ambiguity is there if you consider the pre-order and post order. So using this example, what you can finally conclude? You can conclude that the binary tree is possible using pre-order and post-order sequence, but it need not to be unique. Because you can see that using this pre-order and post-order, you are able to create the binary tree. But there may be a possibility that you created this tree, someone created this tree, and some other person has created this particular tree. So there is an ambiguity, because of which the unique binary tree is not possible using this pre-order and post-order. So if we consider this in order, we can have a unique binary tree. So if we have to create the unique binary tree, so unique is possible if we are having pre-order and in order, or post order and in order. So what you can conclude, that in order is compulsory. So if in order is there, that means you are able to create the unique binary tree. But if this in order is not there, you will not be able to uniquely create a binary tree. See these two examples. Here we are having pre-order and in-order, and we are able to create a unique tree. Here we are having post-order and in-order, and here also we are able to create a unique tree. But here we are having pre-order and post-order, and we are not able to create a unique tree. That means it is not trivial, it is not efficient to create a binary tree using the pre-order and post-order. And in the next video, we will be understanding that how you can work on the binary search tree. Here we work on the binary tree, so these questions are also very important. But in the next video, I'll be discussing the questions on binary search tree, which are very important, because in binary search tree there is no need to find out the in order. You are able to find out the post order if pre-order is given. You will be able to find out the pre-order if post-order is given. So I will be discussing that in the next video. Till then, take care of yourself, keep supporting, keep learning, and if you have not subscribed, please subscribe this channel and like this video if you are able to learn something new. Thank you very much for your time. Keep supporting, keep learning. Have a great day.